All right, so without further ado, today what I'm going to talk about is a newer service that we brought to the Azure platform called Azure API Apps. And in particular, I'm going to focus on a lot of different scenarios with which you can use Azure API Apps when you're building web apps, mobile apps, as well as logic apps. And so we're gonna look at all these today. I do want to remind everyone to please scan at the end of the session and submit feedback. Would love to learn some of your impressions about this new service that we're bringing, and of course, love feedback in terms of how we articulate it, how we present it, and those sorts of things. It helps to teach us quite a bit. I see, okay. So today, here's the agenda. This is what we're going to walk through. So we're going to talk about some of the challenges that you've told us that you face when authoring as well as consuming APIs. We're going to talk a little bit about the architecture of API apps. We're going to spend time focused on authentication. We're going to look at all the different languages and tools and SDKs that you can use in order to interact with the Azure API apps. We're going to try to talk to some on-premises services as well. We'll give that a try. And then, of course, we've got SaaS connectors, and we're going to look at logic apps at the end. So a whole bunch of different things. In fact, what this, I think, helps to reinforce is that these Azure API apps are a foundational piece of some of the app services technology that live within Azure. Now, the last couple of days, I've spent a lot of time at the booth. I've probably spoken to a lot of you. And even in the weeks before the conference, we've spent a lot of time talking to developers about some of the challenges faced when interacting with APIs. And here's just an enumeration of some of these. All the manual plumbing that you end up having to write when building out new APIs, whether it deals with logging or authentication or single sign-on, interacting with secret stores or configuration, and heard a lot about versioning and updating of the APIs as well. Integrating into on-premises services is a key need felt by a lot of people, and there's pain around that as well today. And so that was one of the difficulties as well in terms of authoring API apps, being able to connect to the data that you have in the enterprise that does not live within the cloud, as well as connecting to SaaS investments, whether that's Office 365 or Salesforce or Dropbox or some other API that you end up consuming as part of your enterprise. Governance and monitoring of APIs, understanding how people are using your APIs and having control over it, as well as just some of the complexity around the existing architectures, providing some impedance and preventing you from being able to connect to these APIs. Does anyone feel or agree with some of these challenges? Yep, I'm seeing a lot of nodding heads. I heard some yeses. So now on the other side, when it comes to consuming APIs, yet again, a lot of feedback that we've received. We all consume and we all author APIs, but that's not to say that it isn't difficult and that it couldn't be made easier. And as you start looking at providing APIs to support the business and support your customers and your companies, that's almost next to impossible to expose some of these APIs in a way that makes it consumable for them. All over the board when it comes to metadata and how we describe our APIs, as well as authentication. And over and over, we hear about this lack of being able to scope APIs at an organizational level, being able to describe a set of APIs that are important to this organization versus another one to another organization. And then, of course, at the end, and I don't know that we'll solve this today, but it's always a lack of good API documentation. And so this is one of these issues that we enumerate in these couple of slides are some of the drivers for why we started looking at creating what we've called Azure API Apps. And so what Azure API Apps aspires to be is a platform and an ecosystem, and I'll talk about that in a moment, that makes it easier for you to build and consume and distribute APIs in the cloud and on premises. So why Azure API Apps, and what is it that we're accomplishing? So actually, standing in the hallway before the talk, I was speaking to a gentleman that asked me beforehand, why Azure API Apps instead of just web apps? What's the difference? And I think that's a very good question and something that I want to spend a little time talking about here before we go any further. On the left side, you're going to see a bunch of benefits that come with the Azure App Services platform. And so that includes web apps as well as API apps. Being a part of that platform means that these services automatically get to take the advantage of things like automatic OS patching, enterprise-grade security, high availability, and all the other things enumerated in that list. And so API apps, in a sense, is built on web apps and built on the app service, which means that it gets inherently all these advantages. But there's a few other things that come with API apps that we think bring value to API app developers as well as consumers. And so these are some of the things listed on the right side here. So bring your API as it is. Don't have to rewrite your API. If you're a .NET developer and you're authoring your API and web API, that's fantastic. That'll work fantastically on Azure API Apps. If you're writing in Go or Node, you can still use those APIs the way that you've authored them within Azure API Apps. We're not asking you to change how you build your APIs. We provide mechanisms for simpler access control, and we're going to spend a lot of time looking at authentication here. Connectivity to SaaS platforms. Having access to connectors, which I'll also show you and talk about here, makes it easier for you to connect to these SaaS services that you care about. We have taken a hard look at different metadata formats and have really started to pivot around Swagger. I'm not sure if you're familiar with Swagger. It's a way of describing REST APIs. And one of the things that Azure API Apps does really well is helps you describe your APIs with Swagger so that it becomes easier to use your APIs elsewhere, whether it's consuming it from your web apps or interacting with it via logic apps as well. We've got some very specific Visual Studio tooling and support, which I'll show you here shortly. And we do have a public marketplace today where you can go and get third-party, and first-party being Microsoft, Azure API apps that already exist. So you can very easily instantiate them, and I'll show you that. Now, I do list private marketplace there as well, and that is something that we'll be bringing in the future, and I'll talk about at the end of the talk. But the idea that you can also create and then have in a private organizational gallery the API apps that you care about versus having to make them public to the world. Now, two other things listed here, which are also things that we're bringing to the platform, are just like NuGet has a way of managing dependencies between libraries and some of the runtimes that you use, also with Azure API Apps, you can describe dependencies across Azure API Apps as well. So that if you're using an Azure API app within your custom Azure API app, you can describe that dependency, and when it gets deployed and managed, it will end up using that dependent Azure API app. And then the last thing, which we think is really exciting as well, is we use semantic versioning on the Azure API apps as a way to manage version. And you can opt into having Azure API apps automatically updated when the package is updated as well. So these are a bunch of different things that we've brought with Azure API apps that we think help to solve some of those challenges. And so what I want to do is, with that, show a first demo of how you can build and interact with these Azure API apps. So I'm going to switch over here. Now, I'm going to start here at the vNext Azure portal. I'm assuming most of you have seen this by now. And there's the first class experience for creating a new Azure API app. We can go new, choose web plus mobile, and you'll see there's a whole bunch of different apps available. And of course, we care here about the API app. Now, when you create an API app, I'll talk about the architecture here in a little bit to reinforce some of these things. But a couple of different pieces of infrastructure actually get deployed the first time. And what's also important to be cognizant of is some of the choices you make when building your API app. So for instance, here, I can give it a name, and I can choose a service plan. Now, a service plan for the Azure API app is just the same concept as it is with a web app. When you choose your service plan, you're actually choosing the infrastructure that's hosting your API app. So the actual machine, the virtual machine. So you can have multiple API apps deployed and running on the same infrastructure by choosing the exact same service plan. So here I could choose a service plan that already exists, of course, pricing tier, and then resource group, which becomes a logical container for the resources that I'm deploying, and a subscription that I can deploy. So I'm just going to go ahead and deploy that. Now, what's happening when I create it is it's going to use the Azure Resource Manager to instantiate and create some infrastructure. And it takes about 1.5 minutes to create, but once it's there, in your resource group, you'll have a gateway, which we'll talk a little bit more about in a moment, as well as the API app. Now, just for the sake of time, I have one already created, and I haven't done anything to it. Right here, it's called the Face Detection API app. So I'm going to go ahead and select that. Now, when I open it up, you'll see here the Azure API app Blade. And in this blade, we have a bunch of information pertinent to this API app. I'm going to spend a little bit of time talking about some of it. For instance, if you look here, you can see that I've got a couple of things, some of the resource group that we showed before, subscription, but I also have this API app host and gateway. Now, the API app host is the actual web app that the API app is running on. So if you want to get to the web app to do different things like maybe set up continuous integration, which I'll show in a moment, or change the way in which it scales, you can select the app host and actually go to the underlying web app and make those changes. Similarly, if you want to make changes to the gateway, which runs in its own web app host, you can select the gateway there and start making changes to it. I'm going to spend time later talking a little bit more about things like API definition. So what I want to do is first just go to All Settings and to Application Settings and just talk a little bit here about what we'll end up seeing. So you see automatic updates, so you can automatically enlist into updates for API apps, but you can also specify access levels. So what an access level is controlling who can get access to your APIs. By default, there's 3 different levels, or well, there are 3 different access levels. There's, by default, it's set to internal, meaning that only other Azure API apps running in the resource group, the same resource group, can talk to this API app. So by default, it's set up with fairly constrained access levels. You can change that to public authenticated, which means that you can talk to this API app from outside of the resource group, but you have to do so with some sort of authentication, or you can make it anonymous. And so for this first demo, what I'm going to do is just simply make this public anonymous, so it becomes very easy for us to talk to it. And I'm going to make save to that change. And now our API app host is ready to go. Now, there's no code in it yet, so what I'm going to do is switch over to Visual Studio, and we'll start building the app that will deploy into it. Now, the app that I've decided to build is, I think, a fairly representative app of the kind of things that you'll use API app hosts for. In this case, I'm going to talk to a third-party SaaS provider by the name of Alchemy API. And what I'm going to use is their facial detection service so that I can submit a image to their service, and then they'll return some information back. They determine the gender based on the picture. They'll make a guess on age. And then also if they have a public repository of well-known famous people, and they'll actually scan that repository to see if the picture is someone famous or what the likelihood is that they are that person. So let's go ahead and build it. Now, the first thing I'm going to do is actually create a class. Now, I'm going to do a multi-part foam post to this API. So I'm just going to first create a provider that's going to make it easier for me to keep this image in memory. This isn't particularly important for the demo, but I do need it in order for it to work. So let me go ahead and create this provider. And because I can never type well, I've got a couple of snippets here to go ahead and get this going. So this is basically it's a multi-stream provider that's going to allow me to post the image to this web API and then grab the stream so that I can do something with the stream. And what I'm going to do is pass it to the Alchemy API endpoint. So I'm going to come to the controller, and here we've got the values controller. Let's just go ahead and rename this to facial detection. And I'm not going to use these defaults, but instead, let me add a couple of different things. The first things I'm going to add are just a couple of keys. So there's an API key that I'll use in order to access it, as well as the URL for Alchemy. And then let's add the API itself. So here, I've got a method that's going to allow me to post to it. It's going to check to see if it's a multi-part post. If not, it's going to send back a message saying it's a bad request. And then it's using that provider to essentially, down here, take the information that was posted up to it and turn it into a file stream. And now that I have the file stream, I can go ahead and create a new HTTP client, post it asynchronously to the URL, check the status code, and then essentially take the response and deserialize it and then return it back. So essentially, this is just really a wrapper around the Alchemy API, the Alchemy API's facial detection service. So let's go ahead and run this and check it out and make sure that it's running locally. So actually, one thing before I do that, one thing to be aware of is, I didn't really point this out, I forgot to, apologies. You'll notice that the project template for an API app doesn't have everything you might see in a traditional MVC or even a web API app. So a lot of the views and a lot of things have been removed because the assumption is that you're going to be focusing on building your APIs. But there actually are a couple of interesting things that have been added to this as well. Probably the most important is, by default, we've got, that's really interesting. We've got Swashbuckle right here. So you can see Swashbuckle is a NuGet package that's been added. Now what Swashbuckle is it's a library and a set of, it's some code that will interrogate the API that you build in your API controllers and generate the Swagger for you. So it'll describe your API using Swagger metadata. And we can demonstrate that pretty easily by coming in here to the Swagger config. And then a little bit down here, there's a whole bunch of stuff commented. But there's a piece of code here that's commented called enable Swagger UI. So if we uncomment this and run, there is no home controller or initial view. But what we can do now is type Swagger. And with Swashbuckle and Swagger, what it's doing is creating a little harness for me to interact with the API so I can take a look at it and see the descriptions and even in some cases very easily call a get or a post against it. You can also then take this string here and paste it in and see the actual Swagger JSON that describes the APIs as well. And we'll talk more about this later because it becomes very important when it comes to how you interact with the API apps that you build. So I've got it running. Let's go to Postman, and let me just grab the URL here. And in Postman, what we're going to do is a post to the endpoint, API/face detection is what I called it. No, facial detection. And what I'm going to do is add a file. And I've got a couple of files here. So here's Scott. I actually did this earlier to see if it would detect him as a famous person. And we'll see what the results are. So what comes back is some code here. And so you'll see it comes back. We've got an age range predicted of 35 to 44. I assume that's somewhere in the ballpark. Male, so pretty strongly scored as male, and it does not actually detect Scott as Scott Guthrie. So if it did, it would return back some additional information describing who it thinks that the person is. Interestingly enough, I took a picture of myself, and let me go ahead and add that, and I'll send it to the service. And it makes some interesting predictions. Let's see what the result is. All right, so it actually returns, so first of all, age range 18 to 24, which I'm OK with. Male, which is correct. And it's interesting, it finds in this repository of public images a gentleman named Mikhail Khodorovsky, or I can't pronounce it very well. So of course, I had to take a look to see who this was. And I don't know, you guys tell me. So they say everyone has a twin, so maybe I found my twin. At any rate, it's an interesting service. There's a whole bunch of other stuff, but kind of fun to play with. So we've got it running locally. Let's go ahead and see what we can do now to deploy it. So I'm going to go to my project, right-click, and say Publish. And you're probably familiar with this Publish dialog, web apps. You can import, custom, et cetera. And you'll notice that we also have now Azure API Apps in preview. So I'm going to go ahead and select this. And it's going to take a look at my subscription and see if I have any existing API apps. And of course, I do. So I'm going to select the face detection API app. Now, you could also select new. And instead of going through the portal, you can create your Azure API app from VS. I wanted to make sure you guys saw the portal experience. So I'll go ahead and select that. And it sets it up just like web apps. It's going to use a publish settings file. And it's going to end up doing a web deploy and push that. So it should just take a moment. Visual Studio is not responding. Nice. Take a moment to deploy. Since it's already running, it should be very quick. So publish has succeeded. and that's restarting the gateway. Now this is important. If you end up making changes, and we're going to show a scenario where we're going to use continuous integration to make changes, you need to restart the gateway so that it recognizes the Swagger metadata that's been attached to it. So if you ever change the Swagger, you need to make sure that that gateway has been reset. And so I'm going to grab that URL and come back here to Postman, and instead of posting locally, let's go ahead and switch that to my API app. And we'll just go ahead, well here, I'll choose a different image this time, my friend Adam and I, and we'll click send. And we'll see now we're talking to our publicly anonymous Azure API app that we've got deployed. And we should see a response coming back here momentarily. And there it is. This time we got information about both of us. So that's a very simple look at a first Azure API app, built in Visual Studio, created from the portal. We're going to take it further in a moment, but let me go ahead and come back here to the presentation. So I've mentioned a bunch of this stuff already, but just maybe it bears mentioning again. Azure API Apps, built on web apps, but provides a bunch of additional capabilities as well. Makes it easy to do access control SSO, the metadata contracts provided by Swagger. It's microservice style. One of the things that we really felt inspired by from microservices was the idea of single-purpose APIs and being able to describe and package APIs in a way where they're focused on the purpose of that API so that they're more composable. And so we believe that the way in which you create and package these Azure APIs helps you to deliver on that microservice style of single-purpose composable APIs. As well, and I'm going to show a little bit here on premises and some of the other publishing pieces. So now here is a diagram to hopefully help to make sense of what's actually happening underneath the scenes. So when you deploy your Azure API app for the first time into, let's say, a new resource group, two things will be provisioned. One is the gateway. And so you see on the left side here that there's an Azure App Gateway. And when you're communicating with your Azure API, you're actually communicating to it via this app gateway. And there's a number of reasons for it. Going back to the discussion around challenges for APIs and some of the things that we're trying to make easier with Azure API Apps. One of the things is providing a token store. So if you're communicating to a SaaS API that has a client secret or something that's used to authenticate to it, rather than doing what I did in the first demo, which is I put it right into my Azure API app, you could actually pull that from a secure token store that's provided as part of the platform and available via the gateway. The other thing that helps with this too is it takes advantage of a consent server, which will facilitate some of the things that are needed as part of communicating with SaaS APIs, such as refreshing tokens, storing the tokens as they come back, and so forth. And so that consent server helps to facilitate some of the interactions, the login interactions that might occur otherwise. And we'll see this in effect in Logic Apps here in a moment. Now, behind the gateway is all the additional things that you've deployed, so all the API apps. So you can deploy one or more Azure API apps into a resource group, all of which will then use that application gateway, that Azure API gateway. And so in this example here, you'll see that there's a bunch of connectors, like a Salesforce connector, an Office 365 connector, a Twilio connector. These are Azure API apps that are facilitating connections to SaaS providers. But then you can also deploy custom API apps, just like the one that I wrote for the facial recognition. At the same time, too, there are Logic Apps, and we'll talk a little bit more about them later. But hopefully this helps to just describe a little bit of how these things are organized and some of the different resources that are there. Now, going a little bit in more detail when it comes to the gateway, there's a lot happening in the gateway, and over time, even more will be happening in the gateway. The gateway is what manages not only access levels, so you saw how we could set things to internal or public anonymous or public authenticated, but it also helps to do things like name resolution, being able to resolve how you can communicate to other Azure API apps. That's where it's through the gateway that you get access to isolated storage and shared config. One of the things that I'll show you in the portal in a moment is the kind of API logging that's also available to you via the gateway, so that you can see how many requests are coming in, how many have failed, what are the responses that have been being sent to it, and so forth. So talking a little bit more about authentication, hopefully the 3 levels of access make sense. So public anonymous, so anyone can access it. Public authenticated, which I'll talk a little bit more about in a moment, and then internal. And again, internal being only other Azure API apps being able to talk to it. And I do mean only other Azure API apps. You might expect a web app deployed inside a resource group to be able to talk to an internal Azure API app, but that's not the case. We've decided to, when it is marked as internal, it is only other Azure API apps that can communicate to it. Now, public authenticated is where it gets interesting, because there's a lot of different ways that you might want to facilitate access to your Azure API app. And so there's a number of ways that we provide today, and over time this will continue to grow. The first and probably the most important is Azure Active Directory, and I'll show you how this functions in a moment and how we can set it up and then secure our Azure APIs using Azure Active Directory. You can use an MSA or a Microsoft account, formerly Live ID, as well as some social identity providers such as Facebook, Google, and Twitter. And so I believe, was I on the wrong slide? I apologize about that. Getting all screwed up here. So this is what I just discussed. Now, what I want to do is show how you can add AAD support to your API apps. So I'll switch over. And so what I'm going to do is the same app that we just built that was set as public anonymous, we're going to set to public private and show how we can set it up such that we can communicate to it. So we'll start off in the portal. And I'm going to go to the Azure API app again, and this time set the app setting. Instead of being public anonymous, we're going to set it to public authenticated and save that. So we've set the access level, but we haven't actually defined what identity provider we want to use. And if you recall from the architecture slide, we do that on the gateway. So I'm going to go ahead and select the gateway, which is right here in the blade, and then choose settings. And one of the things that you'll see under settings for the gateway is identity, and it will list out the identity providers that are available today. Now, each one of them requires some configuration. I've found with customers the most questions with Azure Active Directory, so I'm going to demonstrate how we can use Azure Active Directory to secure this endpoint. Now, a couple of things are provided for you when you select this, including an app URL and a reply URL. And this is important in setting up with your IDP so that you know how to facilitate the communication back and forth. You also need to specify what the client ID is for the identity provider you're using. And in the case of Azure Active Directory, we want to specify which tenant, which Active Directory tenant that we want to allow access to. So we're going to go ahead and do that. Now, I'm going to copy this app URL because I'm going to use it quite a bit here. And I'm going to flip over to the current portal, the management.windowsazure.com. And that's because Azure Active Directory only surfaces up today in this portal. So here I've selected Active Directory, and I have a AD tenant here called Wade Wegner. Now this is actually created, so all of you that have an MSA or a Microsoft account in Azure, you also have a AD tenant. In this case, this is automatically created for my MSA, and it's called Wade Wegner Gmail.onmicrosoft.com. So you guys can take a look and take a look at that for yourself as well. Once I select it, I can come here to Applications, and I'm going to create an application specific to the services that I'm securing. So I'm going to say it's an application my organization is developing. You can call it whatever, call it build demo. And it's a web app or web API. And then it's asking for the single sign-on URL and the API app URI. So in this case, we're going to paste that first URL that we got from the IDP settings page so that it points to essentially our gateway /login/AAD. And save that, and it'll create the app. Now, there's a couple other things that we'll need to do. We're going to have to specify what the reply URL is so that it knows where to redirect us after we've authenticated. So I'm going to copy that reply URL and come to Configure. And instead of having it reply back to the login, instead what I'm going to do is put the reply URL in here, and then I'm actually going to also put in HTTP. And go ahead and save this. And so now it knows where to send back an authenticated user. And I'm also going to grab this client ID because I need to specify the client ID in the IDP settings on the previous page. So I'm going to copy that client ID, put it in here, and then specify my allowed tenant. So that is, in this case, Wade Wegner Gmail.onmicrosoft. Microsoft.com, and save that. So at this point, what we've done is we've specified that our Azure API app is public authenticated, and we've now configured our IDP. So let's go ahead and try to give it let's try to interact with it. So actually first, let me just go ahead and demonstrate that it's no longer, I'm no longer able to talk to it. So I'll go ahead and send a request, and I should end up getting back a failure message here in that it could not authenticate to it. It's taking a little longer than I would have expected it to. So I'm going to go ahead and grab this login URL while we're waiting for that and see here. The exception is not the best. I know we are still working on sending back appropriate responses when there's an error. This is in preview still, so. But what I want to do is demonstrate pretty easily how I can now authenticate with Azure AD. So I'm going to actually specify the gateway login. And what that's going to do is, so I have a cookie issue. Let me go ahead and just reset my cookies. So one of the things that I was going to talk about in a moment, but I'll explain now since I'm doing this, is Azure API Apps actually uses the same authentication technology that mobile apps and mobile services use. So using Zumo tokens or Zumo JWT tokens or JOTs. So one of the things that it does is it'll take a Zumo token and put it in a cookie. And I just had a stale cookie there that I had to remove. So now I'm going to go ahead and log in. Now, this isn't going to be the same user that I logged into the portal, since this is actually my Wade Wegner Gmail tenant. So I'm going to log in with Wade at wadewegnergmail.onmicrosoft.com. So it's an actual user in that tenant. And go ahead and log in. And it'll sign in and invalid Zumo header. Demo gods. So let me see if I can just delete this there. Try that again. OK, login complete. Fantastic. All right, so now what I want to do is, since it should have logged in, hopefully it's created an actual, so apologies. So again, what I needed to do is remove a stale cookie. What's happened is now I've authenticated with the AAD provider, and it's created a cookie that I can end up using for authenticating. Now, this is great in interactive web apps where you've authenticated, you've redirected back, and now that cookie is available. You can use it within your application. You can also programmatically get this token using the SDK, and what it's going to get you is this token right here, which is a Zumo token. Let me go ahead and copy this and take no, that's not the full token. Let me try again. Come on. Why am I not getting the whole? There we go. I have no idea why it takes so many copy pastes. This is the full token. And so this is what's stored within the cookie. So when we authenticate, it ends up using this token. Now, what I'm going to do is just to demonstrate that I can authenticate now to this, I'm going to go open up Postman again. And this time, I'm going to attach a header to the call that I made before called x-zumo auth. Paste in that token, select an image again, and send it. And so now when I'm interacting with it, it's passing in the token, and it will get through the gateway as a result, and I'll be able to interact with my API. So, and you can see the response comes back. So apologies for the difficulties there, but we got through it, so thank you. All right, I appreciate that. Thank you. All right, so that's just one example. Of course, there's a bunch of great tutorials on showing MSAs and Facebook and so forth, but we made it through AAD, so fantastic. Now, a little bit more about languages. So one of the nice things about being built on web apps is API apps can take advantage of any languages supported by the Azure web app. And as a result, you can end up writing your Azure API apps in .NET, in Java, PHP, Node, and Yes, even Go. So I'm going to demonstrate here in a moment Go. In fact, I got some cool things around that, but I'll get to it in a moment. We have first-class tooling support today in Visual Studio, but one of the things coming very, very soon, I mean very soon, is we're going to be adding Azure API Apps to the cross-platform CLI tool, which will be great. So, if you're like me, I actually don't always like having to go to the portal and clicking a whole bunch. I'd much rather write some scripts and then run the scripts and have the things that I want deployed. And so very soon we'll have the cross-platform CLI tool, which can run not only on Windows, but it can run on Mac as well as Linux. Now, in terms of SDKs, there is a NuGet package for .NET that makes it easier for you to interact with things like isolated storage and getting access to tokens, and basically managing and simplifying a lot of that for you. And we're going to be bringing more SDKs over time as well for other languages. But in reality, you can do anything and everything via HTTP client. Everything is accessible via the gateway and via your Azure API apps. So using the documentation, you can pull from isolated storage from any language that you want to. One thing that I'm not going to demonstrate, though, that is really neat is given the fact that we have Swagger support for all of these API apps, you can use tools like AutoRest to generate client libraries. How many of you here have heard of AutoRest? A few hands. Take a look at it. It's all open source. It's up on GitHub. There's a tool, AutoRest, that you can get through Chocolatey. You can also get it through NuGet. And what it allows you to do is essentially run against a Swagger JSON file, and it will generate class libraries that you can use for interacting with that REST API. So very, very handy, very nice tool to use in addition to Azure API Apps. So what I want to demonstrate here real quick now is how we can do very much the same thing, but we can do it with Go. Now, one of the reasons that this works today is just recently. Oh, I closed my browser. Well, you can take a look. Just recently, the web apps team that creates Kudu, which is a technology that manages a whole bunch of the management of web apps in terms of continuous integration and all sorts of different things, committed a bunch of code that will take Go language files and actually compile them into binaries and host them. And so what that means is I can now basically grab some Go code. So I'm going to actually grab Go code that I have up in GitHub. So let me go to the repository. And there's a convention in Go where you can do a Go get against a URI, so it defines where the code is. I'm going to grab this here, and I can come into the command line and say go get, and then the project name. And what that's going to do is grab all that code from GitHub, and then let's go into that folder. And you can see here's the Go code. I won't spend a lot of time in here since this isn't the point of the talk, but you can see here is the main function, and it checks to see if there's a platform port, because when it's running up in Azure, it has a different port than it would locally, and so on. The thing I want to point out, though, is Go does not have support for generating Swagger 2.0 like .NET does with Swashbuckle. So one of the things that I think is valuable in this demo is we still can provide our Swagger metadata through a convention, and that convention is to create a metadata folder, and then in that metadata folder, provide a JSON file called apidef.swagger.json. And if you look at that, this is just Swagger data that I created, actually using the swagger.io site that describes my API and basically shows a to-do index and some other things. And so by putting this in this folder, this means that when I go to deploy this Go app, I'll still end up getting access to that Swagger metadata, which means that I can end up then consuming this Azure API very easily from different clients. So in order to get this to work, what I'm going to do is go to the API app that I have deployed for it. And let me go ahead and select that one. So I've got an API app that I had provisioned already called Go To Do API App. And I had mentioned that this is running on a web app. And so as a result, we can take advantage of all of the web app capabilities. So I'm going to go into the web app host. And some of you are probably familiar with the ability to set up continuous integration. So if I slide down here to deployment, once it loads, I can select it and then choose to enable a local Git repository. And so this becomes a great way in order to deploy a code into our API app. So I'm going to choose the source. I'll choose local Git repository. Click OK. And what it's going to do is set up on my API app host a Git repository that I'll be able to commit code into. Now, it's created it. If I select it, what it's going to do is give me some helpful URLs here, like the get URL. There is a bug here right now, and I'll show you what that is. And remember, this is preview, so it'll fix. You can see here it's actually sending the wrong name back. This is not my deployment username. So if I just switch this to Wade Wegner, which is what it is, the rest of this get URI here is correct. So I'm going to go ahead and grab that get URI now that I fixed it. And I'm going to initialize this folder. And I'll do git remote add Azure, and I'll paste in that get URI. And now I can just add my code. I can commit it, initial, and then git push Azure master. And this is where a lot of cool stuff happens once I log in. Is given the updates to Kudu, what it's going to do is it's going to discover that I'm committing a bunch of .go files, and it's going to compile all those Go files down into a binary, update the web.config using the HTTP platform handler to point to that binary, and then my API app is going to start actually accepting requests and responses using this Go code. So you can see all this is happening on my Azure API app via Kudu. Should take a moment to finish. And when it does, we can end up calling into our Go Azure API app. So there it's finished. Oh, one thing I need to do is, by default, this is set to internal. So let's go ahead, before I fail this demo, and switch this to, to public anonymous. All right. And then in Postman, actually, no, I don't even need Postman for this. I'm going to go ahead and just call directly to that. And it says welcome. Not very cool, but watch this. So this is an API app, right? It's not a website. So, to-dos. There we go. I get my JSON back. I can also then say to-dos/1, and so on and so forth. So you can see here, you can author using any language and then using continuous integration via Git or TFS or whatever you might want to end up using in order to get your code into that Azure API app. Thanks. So connecting to on-premises data. This is something that we've been told is very, very critical to our customers. And there's actually a number of different solutions for doing this today. We have inside of web apps something that's been around for a little while called hybrid connections. And so what hybrid connections does is it uses the service bus relay capabilities in order to establish basically establish a TCP connection to a port that you define on your local machine. So I can install some software here, specify what the port is, and then define the service bus relay endpoint. And once it comes online, it'll then facilitate a point-to-point connection between a resource up in the cloud as well as a resource I have running locally. And this is fantastic for developers. It's also very good if you have something like SQL Server or MySQL or something that runs on a machine and you don't want to expose the entire machine to your resources running up in the cloud. So it's very, very surgical in a sense. You can be very specific in terms of what you want to open up on premises. At the same time, we have a technology called virtual networks, which provides a lot of very strong enterprise capabilities for doing things such as establishing site-to-site or site-to-point connections, where you're opening up your network and actually exposing your network and essentially allowing you to extend your network to your resources in the cloud. Both of these are very good options. I think earlier yesterday, Yohai gave a talk on the app service in which they described the ability to establish these site-to-site virtual networks, which was just enabled recently in the platform. It was one of the announcements earlier this week. And so these are very good ways in which you can try to connect to resources local. Now, I'm going to attempt here to give a demonstration with the caveat that earlier today, we did have some issues with the BizTalk services enabling it. So hopefully this will end up going flawlessly. It's a fantastic demo, so I really hope it works. But the reason I'm still going through with it, knowing that it could actually fail, is I think it's valuable to at least go through it, and it's only the end part that may end up failing. So you'll still see how you can do it yourself. So I'm going to go ahead and create a new project. And it's still going to be an Azure API app. And what I'm going to do in this Azure API app is connect to a local database. And so while that's opening, let me open up the SQL Server Studio Management Studio. And I'm going to, in the controller here, let's go ahead and rename this. And we're going to call this Products Controller. And I'm not going to use any of this. I'm going to use this instead. And so what you see here is code that I think is very representative of a lot of the code that you may be writing, others write. And I'm going to get a product. Let me go ahead and create that product here real quick. Okay, and the product's got a product ID, a name, and a price. And here, what I'm going to do is I'm going to select the top 100 products. I just wanted to make sure my connection string is secure. But what you can see here is if I run it locally, it's going to talk to this database right here. And it's going to return back this data. So you can see it there. Now let's go ahead and run it. Oh, one thing I wanted to do first is we're going to use the Swagger UI in order to access it. So let me go ahead and update this setting here so that we turn on the Swagger UI. I wish it was higher up in the file. Yes, like at the top. All right, so let's go ahead and grab that, go into Postman, reset this, and API/products, and send the request. And you can see here I get product ID 1 adjustable rates. Just to demonstrate, I believe, how do I edit this? Edit top 200 rows. Let's just change this price to $5. And execute this again. So you can see it changed to 5. All right, so let's go ahead and deploy this up into our API app, which I pre-provisioned, but I haven't done anything to it. So Azure API Apps. We're going to deploy it to this one here, on-premises Sales DB API app. It's kind of a mouthful. And publish it. Now, while this is publishing, let's go back to the portal. And this is where I'm hoping that the problems I had earlier are resolved. What we want to do is go to the app host and enable the hybrid connection. So, all right, so here it's running. No, not Outlook. And I believe this is the right API app. Yep. And first thing first, let's go ahead and just make sure that we set this to public anonymous, because it's a lot easier that way for the demo. And now I'm going to go to the app host. And again, this app host blade here is really the same thing as a web app blade. So if you slide down, you'll note that we have hybrid connection, once it loads, available as a tile. So I'm going to select hybrid connection. Now, hybrid connections use BizTalk services and the service bus relay in order to establish that connection. So you'll see I don't have any hybrid connections in this resource group, so I'm going to add one. And I'm going to create a new hybrid connection. This will be called on-premises Sales DB. And the host name is my computer name, and port. So one of the things that you didn't see because I encoded the connection string, but it's communicating to my database using TCP. So the connection string goes to the server name, comma, 1433. And so if we establish the hybrid connection, and if it's enabled, and if everything's flowing, then from the cloud, I can still call to my machine on TCP port 1433, and it will be able to talk to my database. So in order to do this, I need to use the BizTalk service, and this is the part that may not work right now. So let's see. And I will say that this is also still in preview. So if I click OK, all right. So let me describe what should happen. So when you click OK, what it'll do is it'll create the BizTalk service, which essentially creates the service bus relay in the background, and it'll allow you to create your hybrid connection. Once you've created the hybrid connection, you'll get another blade that'll open up that will let you download an MSI that you can install, which facilitates the client-side connectivity to the service bus relay. When that's established, this light, well, you can't see it right now because I can't open up an existing hybrid connection, but basically a light turns on saying that your pipe is available, and when we deploy, we should be able to run the same API app in the cloud using the same connection string that we did locally in order to talk to our database. It's a fantastic demo. Maybe sometime I'll get an opportunity to give it again. So, yes. All right, so how are we doing on time? Got a few minutes left. So one of the things that we'll talk about before we're done is connectors. So there's a lot of connectors that we made available when we launched App Service and API Apps. And you can see here everything from Chatter to Dropbox to Azure Media Services are all available as connectors. Now, these connectors are really nothing more than Azure API apps that have been set up such that they make it very easy for you to connect to these SaaS providers. What they also do is facilitate a lot of different types of protocol and protocol communications. So you'll find adapters for connecting to, via FTP, SMSMP, POP3. So the BizTalk team did a lot of work in order to take these capabilities and bring them over as connectors. And then even some of the services that BizTalk Services provides around, batching and validation and, all the Vetter type operations are also available as SaaS connectors. Now, these SaaS connectors today really are designed to facilitate logic apps. This talk is not on logic apps. There's a fantastic talk tomorrow by Steven and Ilya, and they'll describe logic apps and show all kinds of amazing things, because that's what they do. But I'm going to show a little bit of it because I do want to demonstrate that the API apps that you build can also play in this ecosystem of logic apps. So you can build API apps that then get, because of the fact that we're using Swagger and Swagger 2.0, you can end up using them as part of these logic apps that you build. And so let me go ahead and just show some of these things in action. Oh, wrong place. So again, for the sake of time, what I did is I deployed a few of these API apps ahead of time so that we could use them. But I'll just show you the experience here. If you go New, Web plus Mobile, and then Azure Marketplace, you can come here. There's a lot of different things available in the Azure Marketplace. If you select Azure API Apps, what you're going to see are pretty much all the different connectors that are available. And so you can select one of these connectors, decide to create it, and in some cases, you can deploy them right away. In other cases, you may have to provide some credentials or keys or something that helps to delineate you from other consumers of that SaaS provider. When you don't, it's typically because logic apps are using their own credentials to facilitate some of the consent and authorization pieces with that SaaS provider. So I mean, I'll go ahead and click Create just to the fact that it will create. It'll take a couple minutes. But what you'll see here is I already have a Twilio connector and a Twitter connector. And so what I'm going to do is, especially for the sake of time, is I'm going to come in here to Web and Mobile, and I'm going to create a logic app. I'll just try to quickly call it Build Demo and create it. Now, the thing to note is make sure that you create your logic app in the same resource group as the API apps that you want to use so that you have access to them. And when this creates, what we're going to try to do very quickly, since we only have a few minutes left, is create a logic app that will pull from Twitter on a keyword and then send an SMS message. So very simple demonstration, but hopefully we'll reinforce the capabilities and ways in which you can use connectors in Azure API apps within the platform. So, all right, good. Usually it doesn't take very long to create a logic app. So let's go ahead and open this up. Now I'm going to select Twitter since it has a built-in trigger so that it can actually poll for different keywords. So we'll authorize it. And that is authorizing using my credentials. And we'll say, look for new tweets. Now, for Wade Wegner, now you notice I put 2 @ signs in there. That's because @ is a special character, and so we're escaping it. Save that, and then I'm going to add Twilio. And so you probably know where I'm going with this. So if any of you have a Twitter account, you can participate. So I'm going to choose Send Message. Now, one of the things that's nice is with Swagger, we can detect the outputs of one connector and use them as inputs in another. So I can say text, and I can say tweet text. And then here, let's see, I have my Twilio number I can paste in here. And then, yes, this is my actual number, so you can all call me and tell me how well I did. All right. And so with that, I'm going to save it. And I have my phone here somewhere. And so now, let's go ahead and run it now. And at some point, if someone ends up tweeting anything with my name in it, and I can see Steve's on his phone, maybe he's helping out the demo. But at any rate, this workflow should start running. And presumably, anytime the Twitter connector sees something with @WadeWegner, it will end up sending me an SMS message. So what's that? Yeah, let's use up my messages. So fortunately, there's a quota. So at any rate, hopefully this will start dinging. But that should demonstrate at least how it did just ding. Here it comes. So demonstrates how you can use connectors as part of building these logic apps. All right, so to wrap it up, I'm going to turn the sound off now. All right, so in summary, one of these things, the Azure API apps provide a number of benefits here, ways to make it easier for you to authenticate and authorize users into the platform. The metadata alone, I think, is very compelling in terms of consuming and interacting with these API apps. The on-premises connectivity is fantastic, I promise you. And then being able to create connectors and participate in these logic apps, I think, is also a very compelling thing. Now, a couple of things that I want to mention, things that are coming hopefully in the near future, but things that we are working on. Today, we have a public gallery, but for you to get your API apps into the public gallery, you need to be working with us manually, so we onboard you. One of the things that we'll be bringing very soon is self-service onboarding into our public gallery. So just as we have NuGet, and you can create NuGet packages and upload those NuGet packages, and everyone can benefit from them, in the near future, you'll be able to create your own Azure API apps, package them up, and submit them into a public gallery where people can then go and deploy and instantiate your Azure API apps. So watch for that. We are also going to be bringing private and organizational galleries in the future, so that if you're in an enterprise and you have a bunch of IP and you want to make it very easy so that you can deploy and update and manage those Azure API apps, you'll be able to package them up and put them in a private organizational gallery. We are bringing monetization to the platform in the future as well. And in a moment, I'm going to give you a link to a user voice forum where we'd love your feedback. We'd want to know how you want to monetize your Azure API apps. But we fully intend to give you the ability to create some compelling Azure API apps, put them into the community, and find ways in which you can make some money on them. And then lastly, and I put this here because a lot of the questions that we get are, well, what's the story between Azure API Management and Azure API Apps? It seems like there's a lot of overlap. And to a degree, there is. And one of the things that you're going to see in the near future is these two technologies converging. And a lot of the capabilities of the Azure API Management coming to Azure API Apps and vice versa. So there'll be a lot of better together scenarios with those two technologies. And with that, here are some of these resources where you can learn more. There's a bunch of fantastic documentation. We'd love to get your feedback. It's a very active user voice forum. And there's also a forum where you can ask questions if you get blocked. Of course, for those of you that participated in the Logic app, you already have my Twitter name. But there it is if you want to reach me on Twitter. Of course, my email address as well. And thank you guys very much. I'm going to go ahead and load this. Thank you.